For the next part of the robot, we have our phase mechanism. It's pretty standard, a pretty standard design, but we have a band on the outside, which is a little special. And this is actually the furthest point out of the robot. So essentially, our phase just works like this. And the better thing, it just flips around through the bar. And the bar helps actually support the robot. We never had any phasing issues during the tournament. So that's pretty nice. So what the bar does is this little flap right here. It makes sure when the bar goes through, it shoves it all the way up. And the bar also helps support the robot while it's going. We have this large platform on our drivetrain. That's to hold the phase in place. And essentially just swaps between these two directions. And the same is on the other side right here. It's the same thing. And so moving on to our drivetrain, I'll just flip the robot over real quick. There's also some architectural in there. So our drivetrain is 1.5 to 1, I believe. It's a speed ratio. We wanted to use originally wanted to use a 2:1, but we just couldn't find a way to fit it very well. So we ended up using a 1.5 to 1. So effectively, it's just a 36 tooth gear spinning the 24 tooth gear. These are just like idler gears. And so our drivetrain's faster, a lot faster than most drivetrains, which gives us a lot of advantage, helps us move around the field really quickly. And we just have a gyro here, and it's a 2-motor drive. And our brain is mounted right here. So this is our elevator mechanism. It's pretty standard. We do use a 2:1 ratio on our elevator. Since we have the clutch, it essentially enables it to go up much faster. And we probably could use the higher ratio on. I'm just turning on. We probably could use a faster ratio, but we just kept it safe with the 2:1, just because this can easily lift all the bubbles off. And so it's pretty standard. It just goes up, and it falls down because it can't because the PTO locks one way, the clutch locks one way and delocks another way. I'll go more into detail on that on our section about our clutch. But essentially, it just lifts it up and it drops due to gravity once it's released. So here's our elevator in action. That's it for the green blocks. This thing can hold 36 screens, not including the ones we can hold in the intake. And for purples, they just come up onto this part. And we essentially can release them all. We use pneumatics, and you'll notice that these two are separated because we can actually only lift one side if we want to, or both at the same time. So this essentially enables us to flexibly score purples for some rounds. And as for this part, we did spend quite a bit of effort trying to make this as efficient as possible, especially when we cleared supply. If we dropped a block out, it would be really punishing. So we tried to essentially make this as good as possible, so we will minimize block dropping. So this robot, you'll notice that most robots have the wall all the way back here, which means they essentially can't corner score. But we can corner score because we just have from this wall in, we have quite a bit of space, and we can very reliably corner score because we found it's really better for our drivers, and our drivers really like it, the flexibility of being able to corner score in a match. This is probably the part that most people want to see about our robot. We're going to talk first about where we put our pneumatics, and then about our clutch. So for the pneumatics, we had a lot of problem adding them in, just to make sure the robot, the elevator, can go fully down. As our PTO mechanism, clutch mechanism is actually really good, it's a bit tall. And we definitely could have mounted it more down, but there was a bit of a rush job before Worlds. So we have our pump right here. It's pretty down. I'll flip it over. It's mostly down, just high enough so it doesn't get in the way of the phase. And on the other side, in pretty much the same location, is this solenoid right here. It is really down, and we had a lot of trouble wiring the pneumatics with the tubes to this solenoid. But we did it, and because we need 2 solenoids for the expansion and the 2 purples. And our next two items are pretty self-explanatory. We have a pneumatic pressure tank right here, and we have another solenoid. These 2 power our purples, and this one powers our expansion. And this we actually had to band this tank down, because if we attach it with pins normally, it would be too high for the elevator. So it would block it because the elevator's at a slant. And now onto the clutch. So it's a pretty normal clutch. It just goes from one side to the other, and it locks on one side, and it delocks on while spinning another direction, which is why we can't outtake. And so we actually needed to add 2 gears for elevator right here. So we need to right down here. We need to have 2 gears for elevator, just so we can switch like the way it turns to make sure the elevator goes up when it locks. The direction it locks in is the way the elevator goes up. And the same for the intake. When have to add an extra gear here instead of just directly using the larger sprocket, just so we can switch the direction the intake goes, to make sure the direction that spins intakes is the direction the clutch locks. And so we have 4 motors on our clutch mechanism, so which is why we can have such a high ratio intake that doesn't jam and such a fast elevator. And so because we're still in the hotel, we don't have a purple cube with us, but we can show you the robot in action with just like 1 cube, I guess.